Hey, alright. So for now I'm going to write my equation, or not my equation, my question on the board. I feel like that helps better than writing in the description. I guess all the people do it on YouTube, so I'm going to do it too, even though you don't know the problem. Anyway, a car travels alongside a straight road and its velocity time function is illustrated. Find the final displacement of the car. Now I draw the function, and this is about as pretty as I can draw, so um, actually, let me write. This is time, and this is velocity. Now, the thing is that this question, more than being a math problem, I mean, it is a math problem, but what it wants you to do is realize what an antiderivative really means. Alright, so I'm going to go over that. So think back when you learned about regular derivatives. You had your displacement function, okay, s of t, s being displacement and t being time. So the function of displacement in terms of time, right? I'm just generalizing for anybody here now. So s of t, when you had a function, let's say it was, I don't know, 3x cubed plus x squared plus x minus 5, right? Let's say that was your function. Then to find the velocity, how fast it is going, you had to take the derivative, right? So velocity of t was 9x squared plus 2x plus 1. And then to find the acceleration, you took the derivative of the velocity function or the double derivative of the um, displacement function. So a of t equals to 18x plus 2, right? Now, here's the thing. This is what most people don't get. dy dx, with that I mean derivative, is the opposite. What's the symbol for opposite? I don't know. Is opposite of integral of dx. dx being the function, or f, that's right, f of x dx, alright? So, that's what you have to realize. So, for example, if I tell you that, well, I don't know how to, okay, let's see. So, what that means is, if you're going, if you're taking the derivative to find the velocity when you have displacement, and then take the derivative of velocity to find acceleration, take the integral, antiderivative, is going the opposite. If you have the velocity function, you want to find displacement, you take the antiderivative. Now, you don't know how to take an antiderivative yet. By the way, the antiderivative of 9x squared plus 2x plus 1 would be 3x cubed plus x squared, but you haven't actually learned that yet. So what you need to be concerned about is what you did when you didn't know how to take a derivative yet. When you didn't know how to take a derivative yet, what was the derivative really telling you? It was telling you the slope of the function that you were analyzing, right? Derivative is slope. Integral is area, right? We're looking at area under a curve. So when you were looking at how fast is the function going, you were looking at the slope, right? You were taking the derivative to find the slope. Now, for integrals, you want to see the function that you have is the slope of the function you want to find. So you're taking a step back in a way. So you're taking the integral. And how you do that is you find the area under the curve. If you want to take the derivative, you would go one step forward. If you take the integral, you go one step backward. Does that make sense? So, this is just like physics. If you have ever encountered a physics problem, and I know you have, Sunny, you, where you find the area under the function, what you really were doing is taking the integral. So that's how it links into physics, and that's why physics is based on calculus. Alright, so let's actually return to the problem. This was kind of just like explain the whole thing. So remember, derivative is the opposite of integral. Derivative is going one step forward, integral is going one step backwards from the function you have. So now, if you want to find displacement, remember this is velocity versus time. So displacement is one step backwards, acceleration would be one step forward. If you want to find the acceleration, you've got to find the slope of this um, equation, right? So, finding the area, divide it into whatever you want. I like rectangles and triangles because they're nice and simple. So noticing I have two triangles right here, I can just say that this is a rectangle altogether, and I can say point 1 times your height, which is 60. That is your two triangles right here, plus this, which is the same thing as this, because it's the triangles together. So I'm just going to write a 2 right here. Plus, these two triangles again are the same. They are point 1 times, let me stick with the x because that's what I've been doing, times 20, because the height is 20. And again, this thing is there twice because of the rectangle in the middle. So the answer ends up being 16. Alright? So here's also a thing you have to realize, alright? Quickly. Here, velocity is positive, which means you're going up in a positive direction, or not positive direction necessarily, but your velocity is going positive, right? Here your velocity is negative, so you're going negative velocity. So you're actually going backwards. Yeah, okay. You're going backwards, okay? So, but here's the thing. So if you would say, hey, if you look at this area right here, I've gone backwards to 4. I've gone backwards 4 units because of this area. And I've gone forward 12 units, right? Because 2 times 1 plus this thing is 12. So I went forward 12 units, but then I went back 4 units. Or, yeah. So really, I have moved forward 12 minus 4, which is 8. But it's asking for final displacement, which means your total area or your total distance traveled. Okay, so you counted forward. I went 12 forward, and then I went 4 backwards. So my feet traveled, 16 units, while I actually only moved forward 8 units. I hope that makes sense. That was a pretty long elaboration. Anyway, cool. Check out my markers. I think they're pretty cool. Okay. Peace.